the last city on Earth has already fallen silent. And somewhere in the dust and broken concrete, a gold ring is still catching the light. That image came to me years ago when I first started pulling on this thread, and I have never been able to shake it. Not because it is poetic, because it is accurate. Because when everything we have ever built is finally gone, that ring will still be there. Still warm-colored, still heavy, still completely indifferent to the fact that every single person who ever called it theirs is dead. Let me tell you something that took me a long time to fully absorb. The story of gold is not a human story. We showed up to it extremely late, the way you arrive at a party that started billions of years before you were born and will continue billions of years after you are gone. We walked in, grabbed the nearest shiny thing, built entire systems of power and meaning around it, and told ourselves we were the point. We were not the point. We are barely even a footnote. And I know that sounds abstract right now. I know it sounds like something you say at the beginning of a video to sound dramatic. So let me make it concrete. Right now, as you are listening to this, the actual origin story of every gold atom on this planet is so violent, so incomprehensibly large in scale, that if it happened again in our neighborhood of space, there would be no Earth left to stand on. No sun. No solar system. Just a shock wave expanding outward through the dark, carrying with it a fresh cloud of newly born gold. That is where your jewelry comes from. That is where the gold in the circuits of the device you are using right now comes from. From something that would erase us without even registering that we existed. I remember the first time I really sat with that idea. Not just understood it intellectually, but felt it. I was holding a coin, just an old coin someone had given me, turning it over in my fingers. It was warm from my hand. And I thought, this thing was not made on Earth. Not originally. The atoms in this coin traveled across an unimaginable distance, across an unimaginable stretch of time, through events that dwarf every war and every empire and every cathedral ever built. And I am holding it between my thumb and index finger, like it belongs to me. That is the thing about gold that nobody really talks about. We spend so much time arguing about its price, its scarcity, its role in economies, whether it is a good investment. And all of that conversation happens at this tiny surface level, like two people arguing about the color of the paint on the hull of a ship that is already at the bottom of the ocean. The real story is underneath all of that. The real story is so much stranger and so much darker than anything our financial systems or our legends have ever managed to capture. So here is what we are going to do. We are going to start at the actual beginning, not the human beginning, not the point where someone first picked up a shiny rock and decided it was special. We're going to start at the moment when the universe first had to decide what gold even was and what it would take to make it. And I promise you, by the time we get to the end of this, the way you look at that ring on your finger or that chain around your neck is going to be fundamentally different. Not because gold is less valuable than you thought, but because it is something far more unsettling than valuable. It is something that was never meant to be here at all. If this kind of story is what you are here for, do me a favor and subscribe and hit the like button right now. It genuinely helps more than you know, and we are just getting started. Here is the part that most people never stop to question. We did not choose gold because it is useful. Gold is actually terrible for most practical purposes. It is too soft to hold an edge. It is too heavy to carry in large amounts. It does not keep you warm, or feed you, or protect you from anything. And yet, across every continent, across cultures that had zero contact with each other, across thousands of years of completely separate human development, the same conclusion was reached independently again and again. This yellow metal is the most important thing. This is what power looks like. This is what the gods want. This is what we will trade, hoard, bury with our dead, and go to war over. That kind of universal agreement across completely isolated civilizations is not a coincidence. It is not a quirk of taste. Something deeper is happening. And I think the reason we have never fully confronted what that something is because the answer is uncomfortable. Because the answer suggests that gold has always had a relationship with us that we did not initiate and do not fully control. Think about what gold actually is, just on a sensory level. Pick it up, and it is heavier than it looks. That slight shock of unexpected weight, like the object is more real than the world around it. Hold it in the light, and it does not just reflect the light the way silver does, bouncing it back clean and cold. Gold seems to hold the light for a moment, to absorb it, to give it back warmer than it arrived. Run your thumb across a polished surface, and it is smooth in a way that feels almost organic, almost like skin that never ages. It does not smell like anything. It does not corrode, does not tarnish, does not leave a green ring on your finger. In a world where everything rots, everything rusts, everything eventually falls apart and disappears, gold simply does not participate in that process. It opts out of decay entirely. And I think that is what our ancestors were actually responding to, before they had any words for chemistry or physics. They were responding to the fact that this thing does not die. In a world where death was everywhere, where food rotted and wood crumbled and iron turned to dust, here was something that looked the same in the morning as it did the night before, the same after a year, the same after a century. They did not know why, but they felt it. They felt that they were holding something that operated by different rules, something that had come from somewhere outside the normal order of things. They were more right than they could have possibly known. Because gold did not come from inside the normal order of things. It came from the most catastrophic event the universe is capable of producing. And to understand what that actually means, we need to go back to a time before this planet existed, before our sun existed. Back to a moment when the universe was running a process so extreme and so final that the word explosion does not even begin to cover it. The universe started with almost nothing, and I mean that literally. Not darkness, not emptiness, not some vast, quiet space waiting to be filled. Nothing. And then, in a single event that no human language has ever found the right word for, everything that exists exploded into being simultaneously. All the matter, all the energy, all the space itself arriving at once. The temperature in that first moment was so extreme that the number describing it would take longer to read aloud than you have been alive. And out of that absolute maximum of heat and chaos, the universe managed to produce exactly two things in any significant quantity: hydrogen and helium. That is it. That is the entire periodic table as it existed in the beginning. Two elements. Two simple, lightweight, invisible gases drifting through the newborn dark. I want you to sit with that for a moment. Because everything you are made of, everything you have ever touched, every metal ever pulled from the ground, every bone, every drop of water, every grain of sand, none of it existed yet. The universe had the raw ingredients for exactly two things, and neither of them was gold. Gold had to be invented later, under conditions that make the Big Bang look like a warm-up act. So the hydrogen and helium drift and cool, and gravity does what gravity always does. It pulls. Slowly at first, then faster, clouds of gas collapsing inward under their own weight, compressing, heating up from the inside as the pressure builds. And eventually, in the core of these collapsing clouds, something ignites. The first stars switch on. And when they do, the real manufacturing begins. A star is essentially a pressure cooker running a nuclear process at its center. Hydrogen atoms are crushed together so hard that they merge, releasing energy and producing helium. That energy pushes outward, the gravity pulls inward, and the star sits in that tension for millions or billions of years, steadily converting one element into another. Small stars, stars like our Sun, can do this with hydrogen and helium, and not much else. They are modest factories. But the truly massive stars, the ones that burn hundreds of times hotter and live fast and die young, those stars keep going. They produce carbon, then oxygen, then silicon. They climb the periodic table one step at a time, each new element requiring more pressure, more heat, more extreme conditions than the last. And here is where the story gets genuinely strange. Because as these massive stars climb toward heavier and heavier elements, they are not just making atoms. They are racing against their own destruction. Every step up the periodic table costs more energy than the last. The star is burning through its fuel faster and faster, and the elements it produces are becoming harder and harder to fuse. It is like a machine that has to consume more and more of itself just to keep running, getting louder and hotter and more desperate with every passing stage. You can almost feel the urgency of it, the mounting pressure, the sense that something enormous is about to give way. And then the star reaches iron, and everything stops. Iron is the wall. Iron is the point where the universe says, "This is far enough." Because every element the star has made up to this point released energy when it was formed. That released energy is what kept the star alive, what pushed back against gravity, what maintained the balance. But iron is different. Iron does not release energy when you fuse it. It absorbs energy. It is the one element in existence where the nuclear math flips from profit to loss. And a star that starts accumulating iron in its core has just signed its own end without knowing it. The iron core grows. It cannot burn, cannot contribute to the energy output, cannot do anything except sit there and get heavier. And as it grows, the outward pressure that has been holding the star together for millions of years starts to lose the argument against gravity. Not gradually, not slowly. In less than a single second, the entire outer structure of a star that might be 50 times the mass of our Sun collapses inward. The speed of that collapse is so fast that the outer layers actually bounce off the suddenly rigid core, and the rebound blasts outward as a shockwave that tears the entire star apart. The explosion is visible across distances so large they have no meaningful comparison to anything in human experience. For a brief window of time, a single dying star outshines the entire galaxy it belongs to. Billions of other stars, and this one death is brighter than all of them combined. The shock and the heat and the flood of particles that pour out in those final moments do produce some heavier elements, things beyond iron, scattered fragments of the periodic table that would otherwise never exist. But here is the thing that took scientists a long time to accept, and that changes the entire story of gold. The amounts are tiny. A supernova, for all its incomprehensible violence, produces only trace amounts of the heaviest metals, not nearly enough to account for what we find in the universe, not nearly enough to explain a single gold ring, which means something even more extreme must be responsible, something that makes a supernova look like a controlled, orderly event. And when researchers finally worked out what that something was, the answer was so extreme, so final, so complete in its violence, that it took years for the scientific community to fully accept it. Because the process that makes gold is not the death of a star. It is a collision between two dead stars, each one already incomprehensibly dense, each one already representing the collapsed remains of something that was once enormous, finding each other in the dark after millions of years apart, and falling together at speeds that begin to approach the absolute limit the universe allows anything to move. What happens next is not an explosion. It is something for which we do not really have a word. And that is exactly where we are going. Two dead stars, each one containing more mass than our entire sun, hit each other at nearly half the speed of light. I need you to actually try to imagine that for a second. Not just let the words wash over you, but really try to feel the scale of it. Each of these objects is so dense that if you took a single spoonful of its material and placed it on a table in front of you, it would instantly fall through the table, through the floor, through every floor below that, straight through the bedrock, and it would not stop until it reached the center of the Earth. That is what is colliding. Two objects made entirely of that material, each roughly the size of a city, moving toward each other at a speed that covers the distance from here to the moon in roughly 2 seconds. The collision does not produce a sound. There is no sound in space. But the event does produce something that is in some ways more extraordinary than sound. It produces ripples in space itself. Not in anything inside space, not in gas or light or dust, but in the actual fabric of space, the thing that everything else exists inside of. Those ripples spread outward from the collision point at the speed of light, passing through everything, through planets, through stars, through you right now as you listen to this, completely undetectable without the most sensitive measuring instruments ever built by human hands. We actually caught those ripples once, from a collision just like the one I am describing. The instruments recorded it. Scientists stared at the data for months before they let themselves believe what they were seeing. But the ripples are almost a footnote compared to what happens at the point of impact itself. When those two neutron stars meet, the energy released in the first fraction of a second is greater than the total energy output of our Sun across its entire 10 billion-year lifespan. All of that energy, concentrated at a single point, tearing matter apart at the most fundamental level possible. And in that tearing, in that absolute maximum of heat and pressure and chaos, something remarkable starts to happen to the lighter elements that were part of these stars. They get hit by such a dense flood of free neutrons that their nuclei begin absorbing them faster than they can naturally reorganize. The nuclei swell, become unstable, and then rapidly restructure themselves into heavier and heavier configurations. In a fraction of a second, elements that take stars millions of years to produce are assembled in enormous quantities. Gold, platinum, a dozen other heavy metals born in the most violent moment the universe regularly produces. The cloud that expands outward from that collision contains more gold than your mind can process. Not grams, not kilograms, not tons. Quantities measured in units that would require you to stack every gold bar ever pulled from every mine on Earth into a pile, and then repeat that exercise billions of times over. That cloud drifts through space, cooling, thinning, spreading across distances so vast they take light itself thousands of years to cross. And eventually, some of it, a tiny fraction of it, gets caught up in the gravitational pull of a forming solar system. Our solar system. And some of that fraction ends up as part of the raw material that clumps together to form a small, rocky planet in what will eventually be called the habitable zone of an unremarkable star. The gold arrives at Earth before Earth even fully exists. It is part of the original ingredients, baked into the recipe from the very beginning. And if the story ended there, if gold had simply stayed evenly distributed through the material that built our planet, we would be living on a world where gold was genuinely everywhere, woven through every rock and every handful of soil. Instead, something far more frustrating happened. And it happened because of a law of physics that does not care even slightly about what we want. Gravity sorted everything by weight. That is the blunt, simple, completely indifferent truth of what happened to Earth's gold. The young planet was not solid. It was a sphere of molten rock and metal, everything churning and mixing and moving in slow, massive currents driven by heat. And in that churning ocean of liquid planet, density determined destiny. Heavy things sank, light things rose. It was not a fast process, but it was a thorough one. Over millions of years, the densest materials migrated toward the center of the planet, and the lighter silicate rocks floated upward and eventually cooled into the crust we walk on. Gold is extraordinarily dense. Place it next to an equal volume of granite, and the gold weighs roughly 7 times more. In the molten early Earth, that density was a death sentence for any hope of surface gold. But there was an additional factor that made things even worse, and this one feels almost personal in how completely it robbed the surface of what should have been there. Gold has a chemical attraction to iron. Not a metaphorical attraction, a real, measurable, physical preference for bonding with iron over almost anything else. And the early Earth had iron in abundance, all of it sinking toward the core in exactly the same gravitational current that was already pulling the gold downward. So the gold did not just sink because it was heavy. It grabbed onto the iron that was already sinking and rode it down like a passenger on a train that only goes one direction. Down through the mantle, down through the lower layers, all the way to the core, where it has been sitting ever since, under pressure so extreme and heat so intense that no material we have ever made could survive the journey to reach it. Right now, beneath the ground you are standing on, there is enough gold to cover every landmass on this planet under a layer deep enough to walk through. and it is as unreachable as the surface of a star. The crust we live on is, in geological terms, the leftovers. The light, iron-poor, gold-poor foam that floated to the top while everything valuable sank away. We built our entire civilization on the discard pile of a planet that kept the good stuff for itself. And if the story had stopped there, gold would be a purely theoretical concept to us, something scientists hypothesized existed in the deep interior, but that no human hand had ever touched. So why does any gold exist up here at all? Why does it sit in riverbeds and veins of rock and vaults and jewelry boxes? The answer to that question did not come from the planet. It came from space. Again. And the way it arrived was not gentle. Every single gram of gold you have ever seen in your entire life fell from the sky. Not metaphorically, not poetically. Literally, physically fell from space onto this planet like debris from a wreck, because that is exactly what it was. And the event that delivered it was not gentle or gradual or quiet. It was a planetary bombardment so severe that if it happened today, nothing on the surface of Earth would survive it. Here is what happened. After the young Earth cooled enough to develop a solid crust, the solar system was still a chaotic and crowded place. The giant outer planets, the ones so massive their gravity dominates everything around them, were still settling into their final orbits. And as they shifted, their gravitational influence rippled outward through the asteroid belts like a hand sweeping across a table. Millions of rocks, some of them the size of mountains, some larger than that, got knocked out of their stable paths and sent tumbling inward toward the rocky planets closer to the Sun. Earth was directly in the path of that incoming flood. The bombardment lasted for a stretch of time so long it is almost meaningless to state it as a number. Impacts came continuously, one after another, rocks slamming into the surface at velocities that vaporize stone on contact. The ground would have glowed, the sky would have been permanently lit by streaks of incoming material. The crust, still young and relatively thin, cracked and buckled under repeated hits. It was not a world anything could have survived. It was a construction zone being hit by wrecking balls from every direction simultaneously. And those incoming rocks carried something. Many of them were metal-rich asteroids, objects that had formed in the outer reaches of the solar system from material that included the remnants of that neutron star collision we talked about earlier. They were laced with heavy metals, including gold, in concentrations far higher than anything in Earth's own crust. When they hit, they did not sink to the core the way the original gold had, because the crust was now solid. The heat of impact vaporized the incoming material and mixed it violently into the upper layers of rock, blasting fragments across huge areas, seeding the surface with metals that had no business being there from a purely geological standpoint. Every gold mine that has ever been worked, every vein of ore ever followed by a miner crawling through the dark with a lamp on their head, every fleck of gold ever spotted in the gravel of a riverbed, all of it traces back to that ancient rain of foreign rocks landing on a cooling planet. We did not mine Earth's gold. We mined the remnants of a cosmic accident that nobody planned and nobody could have predicted. The gold was never ours to begin with. It was just passing through, the same way it always has been, the same way it always will be. And now, here is the part that quietly unsettles me every time I think about it. The total amount of gold delivered to Earth's surface by that bombardment across all those millions of years of incoming rock, across every impact and every explosion and every cloud of vaporized metal settling back down through the atmosphere, all of it combined, all the gold that has ever existed in every mine and every vault and every piece of jewelry in all of human history would fit inside a structure smaller than most sport stadiums. That is the entire supply. That is what we built empires over. That is what we enslaved people for, what we leveled mountains for, what we poisoned rivers and ecosystems for. A quantity of material that, measured against the scale of the planet that holds it, is essentially nothing. We are not wealthy. We are just the current custodians of an almost negligible amount of space debris, and we have organized our entire concept of value around it because something deep in us responded to what gold is without ever understanding what gold actually is. And that response, that pull, that irrational magnetism that gold has always exerted on human beings is where the story gets personal. Because eventually, humans stopped just finding gold and started trying to understand it. And then, inevitably, they started trying to make it. The first people to seriously attempt that were not scientists in the modern sense. They had no laboratories in the way we would recognize. They had furnaces and crucibles and notebooks filled with observations written in coded language, because what they were doing was considered, depending on the era and the location, either deeply sacred or deeply dangerous, or both at the same time. They believed, with complete conviction, that gold was not just an element, but a kind of perfected state of matter. That other metals were essentially sick versions of gold, fallen from their natural ideal form, and that the right process, the right sequence of transformations, could heal them back into what they were supposed to be. That idea drove some of the sharpest minds of several centuries into obsessions that consumed their health, their relationships, their sanity, and in some cases their lives. And the most extreme example of that obsession, the one that still makes me stop and stare when I read through the historical records, was not some forgotten eccentric working in isolation. It was a man whose other work is still taught in schools today. A man whose contributions to science are so foundational that without them, the modern world as we know it could not have been built. He understood gravity. He understood light. He helped invent calculus, and he spent more time and energy and suffering trying to turn base metals into gold than he ever spent on any of that. His name was Marcus. And what he did to himself in that pursuit is something I am still not entirely sure how to process. Marcus did not just study gold. He consumed it. And I mean that in the most literal and disturbing way possible, because the records he left behind describe a man who regularly tasted his own experiments, who pressed toxic compounds against his tongue to feel how they changed the texture of his saliva, who believed that the body itself was a kind of instrument that could detect truths the eyes and measuring tools could not. He was not reckless. He was methodical about it, which in some ways makes it worse. He kept detailed notes on the flavor profiles of substances that modern chemistry classifies as acutely hazardous. Sweet, metallic, a warmth at the back of the throat that he described as promising. He thought he was getting closer. He was destroying himself one careful observation at a time. The room where Marcus worked smelled of something that does not have a clean name. It was part sulfur, part burning metal, part something organic and wrong, the smell of chemistry being pushed past the boundaries it was designed to respect. He kept his furnace running continuously for weeks at a stretch, feeding it fuel through the night, adjusting temperatures by a judgment built from years of obsessive practice. His hands were permanently stained, the skin around his fingernails a greyish tone that never fully washed out. His eyes, by all accounts, were extraordinary, sharp and restless and always moving, always processing, always looking for the next clue. But the hands told a different story. The hands showed what the work was actually costing him. He was trying to force matter to do something that matter cannot do through chemistry alone. He understood transformation at the visible level, the way compounds changed color when heated, the way certain mixtures produced unexpected results, the way some substances seemed to draw metals out of solution while others repelled them. He was genuinely brilliant at reading those signals. But he was working at the level of electrons, at the surface behavior of atoms, while the problem he was trying to solve required going all the way into the nucleus, into the core of the atom itself, where forces operate at energies so far beyond anything a furnace can produce that the comparison is almost absurd. The gap between what his equipment could do and what the task actually required was not a small gap. It was not something that a better furnace or a purer reagent or one more year of experiments could have closed. It was a fundamental physical barrier that no amount of human ingenuity or dedication or suffering could cross, without tools that would not be invented for centuries after his death. And yet he kept going, because gold does that to people. It convinces the mind that the answer is close, that the next combination, the next temperature, the next procedure will be the one that finally unlocks it. It is patient in a way that human beings are not. It waits while we exhaust ourselves against it. The breakdown, when it came, was not dramatic in the way breakdowns are sometimes portrayed. It did not happen in a single moment of collapse. It crept in slowly over months, the way a structure develops cracks before it fails. Marcus began to see patterns in his work that were not there. He became convinced that certain colleagues were copying his methods, stealing his progress, deliberately sabotaging his results. He wrote letters full of accusations that the recipients found baffling. He withdrew from people he had known for years, convinced they could not be trusted. The paranoia was textbook in its progression, following a path that toxicologists now recognize immediately when they read the historical accounts. When researchers much later examined samples preserved from Marcus's personal effects, the levels of heavy metal contamination they found were extraordinary. His body had been absorbing toxic compounds for so long, through skin contact, through inhalation of fumes, through direct tasting of substances, that the accumulation had reached concentrations capable of causing precisely the neurological symptoms he displayed. The paranoia, the mood swings, the periods of brilliant clarity followed by long stretches of confusion. He was not losing his mind to the mysteries of gold. He was losing his mind to the chemistry of his own laboratory, one experiment at a time. And here is the thing that I find genuinely hard to shake. Marcus failed. He spent decades pursuing something that his tools could never have achieved, and he paid for that pursuit with his health and ultimately his grip on reality. But he was not wrong that gold was extraordinary. He just could not have known how extraordinary or why, because the explanation for gold's most fundamental strangeness requires a framework of physics that nobody in his era possessed. He stared at gold his entire working life and never once asked the question that would have led him closest to the truth. Not how to make it, not where it came from, but why it looks the way it does. Why, in a periodic table full of grey and silver metals, Gold alone carries that warm, almost aggressive yellow color that seems to generate its own light even when the light source is ordinary. That question sounds simple. It is not simple at all. And the answer, when it was finally worked out centuries later, turns out to be one of the most quietly astonishing things in all of physics. To understand why gold is yellow, you need to understand something that sounds completely unrelated at first. You need to understand what happens to an object when it moves very fast. Not fast by human standards, not fast by the standards of aircraft or rockets, fast by the standards of the universe itself, a meaningful fraction of the speed of light. Because inside every gold atom, that is exactly what is happening. Right now, in the ring on your finger or the contacts in your phone, electrons are moving at speeds that begin to push against the fundamental speed limit of reality. And at those speeds, the ordinary rules of physics stop applying. Something stranger takes over. And what that something stranger produces in terms of how gold behaves and looks and why it has held humans in its grip for all of recorded history is the last thing most people would ever expect. The color of gold is proof that Einstein was right, and almost nobody realizes they are looking at it every single day. Let me explain what I mean by that, because this is the part of the story that made me put down whatever I was doing the first time I properly understood it and just sit there for a while. Every metal in the periodic table reflects light in a way that produces a gray or silver tone. Copper is the one exception most people think of, and gold is the other. But the reason gold looks the way it does has nothing to do with chemistry in the traditional sense. It has to do with speed. Specifically, it has to do with what happens to mass when something moves fast enough that the ordinary rules of physics start to bend. Inside a gold atom, the nucleus carries an enormous positive charge, because gold has 79 protons packed into that nucleus. That charge exerts a powerful pull on the electrons orbiting around it. The innermost electrons, the ones closest to the nucleus, experience that pull so intensely that they accelerate to speeds that are a genuinely significant fraction of the speed of light. We're talking about more than half the speed of light, for electrons orbiting inside an atom small enough that billions of them would fit across the width of a human hair. At those speeds, something happens that Marcus, for all his brilliance, had no framework to understand. Mass increases. This is not a theoretical quirk or a rounding error. It is a real, measurable effect that Einstein described in his work on how space and time behave at extreme velocities. The electrons become heavier than they should be at lower speeds, and heavier electrons behave differently. Their orbits shrink. They pull in closer to the nucleus than the math of classical physics would predict. And because their orbits are compressed, the energy gaps between those orbits shift into a different range. Here is what that means in practice. When light hits a piece of gold, the electrons in that compressed orbital structure absorb the blue and violet portions of the spectrum, using that energy to jump between their tightly packed orbits. The red and green portions of the light are reflected back. Your eye receives that combination of reflected red and green and interprets it as yellow. That warm, rich, unmistakable color that has made humans lose their minds across every culture and every century is not a chemical accident. It is relativity. It is the visible consequence of electrons moving so fast that space and time treat them differently than they treat slower objects. If the speed of light were even slightly different, gold would be gray. If Einstein had been wrong, gold would look like aluminium. The entire history of human obsession with this metal, every war fought over it, every civilization built around it, every life consumed in pursuit of it, all of it was triggered, at the most fundamental level, by a relativistic effect playing out inside an atom. We were not drawn to gold because of its rarity or its utility. We were drawn to a color produced by physics operating at a scale we could not see and did not understand for most of our existence as a species. That realization sat with me for a long time, because it means that everything Marcus went through, all that suffering and poisoning and paranoia, was in pursuit of something he could never have explained even if he had succeeded in making it. He wanted to understand gold, but the explanation for gold's most basic, visible property was locked behind a theory of physics that would not exist until long after he was gone. He was asking the right question and looking in completely the wrong direction, not because he was foolish, but because the answer required a map of reality that nobody had drawn yet. And while individual obsessives like Marcus were consuming themselves in private laboratories, the same gold that had broken them was quietly becoming the foundation of something much larger. Governments started to understand that whoever controlled the supply of gold controlled something more important than land or armies. They controlled the thing that everything else was measured against. And that understanding eventually produced decisions so desperate, so enormous in scale, so expensive in human terms, that they make Marcus's private suffering look almost modest by comparison. Because there came a moment in history when an entire nation, a large and powerful one, looked at its catastrophic debts and its suffering population and decided that the solution was not to change its economic system or renegotiate its obligations. The solution was to find more gold. Enough gold to pay off everything, restart everything, solve everything in one enormous stroke. And the person they trusted to find it was a scientist whose credentials were impeccable, whose previous achievements had genuinely changed the world, and whose confidence in the plan was absolute. His name was Leonard, and the plan he proposed was not some fringe theory or desperate fantasy. It was based on real data, real measurements, real scientific literature. He had done the calculations himself, carefully, multiple times, and the numbers were extraordinary. The source he had identified contained more gold than all the mines in human history had ever produced combined. It was not underground. It did not require drilling or blasting or any of the brutal machinery of conventional mining. It was everywhere, surrounding every coastline, covering most of the planet's surface. The ocean. And Leonard was certain, with the kind of certainty that comes from years of rigorous scientific work, that he knew exactly how to get it out. The government gave him ships. The government gave him equipment. The government gave him a team and a budget, and the quiet understanding that if this worked, he would be the man who saved everything. Leonard sailed out into open water, with the weight of a nation's hope sitting in the hold alongside his extraction machinery, and he was absolutely convinced he was weeks away from pulling off the most important scientific achievement in modern history. He was wrong. But the way he was wrong, and what it revealed when he finally understood it, was something that changed how science approached measurement and contamination forever. And it started with something almost insultingly small. Leonard's entire ocean gold project collapsed because of a wedding ring. Not a metaphor, an actual ring worn on the finger of one of his own researchers that had been quietly shedding microscopic particles of gold into every water sample the team collected for months. Every measurement that had looked so promising, every data point that had convinced a government to fund an expedition and send ships out to sea, traced back not to dissolved ocean gold, but to invisible flakes from jewelry that nobody had thought to remove before handling the samples. The golden ocean was a ghost made of someone's marriage. And Leonard, to his credit and his devastation, was the one who figured it out. He went back through every study that had been published on ocean gold concentrations before his expedition. Every one of them. He re-examined the methodology, the equipment used, the conditions in the labs where the analysis was done. And the same contamination pattern appeared everywhere, in different forms, but always present. Gold from instrument casings, gold from the tiny soldered connections inside measuring devices, gold from researchers' own hands and accessories transferred to samples through contact that nobody had thought to prevent because nobody had imagined the concentrations they were looking for were low enough that skin contact could matter. The earlier scientists were not frauds. They were just not careful enough for a problem that required a level of sterility nobody had previously considered necessary. Leonard's ship returned to port carrying no gold and no solution and no hope for the nation that had sent it out. He walked off that vessel a smaller man than when he had boarded it. Not because he had failed exactly, but because he had succeeded in proving that the thing everyone needed to be true was false. Sometimes the most important scientific result is the one that closes a door. Leonard closed this one permanently, and the silence on the other side of it was enormous. I think about Leonard often when I consider how many of our collective beliefs about wealth and abundance rest on measurements that were never properly checked. How many times has a civilization organized itself around a resource that turned out, on closer inspection, to be much smaller or less accessible than the original optimistic reading suggested? The ocean gold story is an extreme version of that, almost cartoonish in how completely it collapsed once scrutinized carefully. But the pattern it represents is not unusual at all. What is unusual is what happened next in the history of gold. Because after Leonard's expedition, the scientific conversation shifted completely. If you cannot find enough gold, and you cannot extract it from where it is dissolved, the next logical question is whether you can make it. And by the time Leonard's ships were back in port, a completely different group of people in a completely different part of the world were already living under conditions where that question had become desperately practical. Not theoretical, not academic, urgently, immediately practical, because gold had become the difference between survival and something much worse. The city had been under occupation for weeks. The streets that had been ordinary and familiar were now patrolled by strangers with authority to stop anyone and search anything. Institutions that had operated for decades under the assumption of a certain kind of safety were suddenly discovering that that assumption had been wrong. And in one particular building, a research facility that under normal circumstances concerned itself with entirely peaceful scientific work, two objects had become a serious problem. They were small, they were heavy. They were made of gold, and they had names engraved on them. And those names were exactly the kind of names that the people now controlling the streets were looking for. The objects were awards, significant ones, the kind given to scientists whose work had changed entire fields, passed to the facility for safekeeping by their owners who had understood before most people that the situation was about to become dangerous and that keeping valuable named objects in their own possession was not safe. The plan had made sense at the time. The facility seemed like a reasonable place to hide things. But the situation had evolved faster than anyone predicted, and now the facility itself was not safe, and the awards were sitting in a secure cabinet, and searches of exactly this kind of building were already happening across the city. The man who understood what needed to be done was a chemist named Daniel. He was not famous in the way the award recipients were famous. He was a working scientist, precise and calm in the way that people who spend their lives around dangerous materials tend to become. He looked at the awards and he thought about the problem the way a chemist thinks about problems, which is to say he thought about the properties of the material rather than the shape of the object. The shape was the danger. The shape was readable, identifiable, evidence. But gold was not just a shape. Gold was a set of chemical properties, and one of those properties, the one that made it valuable, its extraordinary resistance to almost every chemical process known, also meant that very few people would think about attacking it chemically. Very few, but not none, because there existed a mixture known to chemists for centuries that could do what almost nothing else in the world could do. It could dissolve gold completely, reducing solid metal to a solution of ions suspended in liquid, stripping away every visible trace of what the material had been. The mixture was not pleasant. It produced fumes that could damage the lungs in seconds of direct exposure. Working with it required care and focus, and the kind of steady hands that do not shake even when the situation outside the building is deteriorating and the sound of vehicles on the street carries a new kind of weight. Daniel had all of those things. He prepared the solution carefully, measuring the components with the same precision he brought to any experiment. The smell hit immediately, sharp and aggressive and chemical. The kind of smell that registers in the body before the mind has processed it, that triggers an instinct to step back even in someone who knows exactly what it is and why it is there. Daniel did not step back. He worked steadily, and when everything was ready, he placed the awards into the liquid and watched what the chemistry did. What happened next was slow, and then fast, and then complete. And it was one of the most remarkable acts of preservation through apparent destruction that I have ever come across in any account of what gold has meant to people across history. Scientists actually made gold from scratch in a laboratory, and it nearly killed everyone involved, not in an explosion, not in some dramatic accident, but in a slow and invisible way that nobody fully understood until after the fact, which somehow makes it worse. But before we get there, let me finish what Daniel started, because what happened in that occupied building during those years of danger is one of the most quietly extraordinary things gold has ever been part of. The awards had dissolved completely. What had been solid, heavy, engraved objects was now a dark liquid sitting in a glass container on a laboratory shelf. Daniel labeled the container with a routine chemical notation, something that would read as unremarkable to anyone glancing at the shelf, and he placed it among dozens of similar containers holding actual working reagents and experimental solutions. The disguise was not elaborate. It did not need to be. The genius of it was that it required no hiding at all. The gold was invisible not because it was concealed, but because it no longer looked like gold. It had been chemically transformed into something that carried no visual signal of its value. Search teams came through the building. They were thorough in the way that people with authority and time tend to be, opening drawers, checking behind furniture, looking inside equipment. They passed the shelf where Daniel's container sat. Some of them passed it multiple times over multiple visits across multiple months. Not one of them touched it. There was nothing about a small bottle of brownish liquid sitting among other small bottles of brownish liquid that suggested anything worth taking. They were looking for the shape of value. They were looking for something that looked like gold. Daniel had simply removed that shape from the equation entirely while leaving the substance itself completely intact. The container sat on that shelf through seasons of cold and heat, through the sounds of a city living under conditions it had not chosen, through years of quiet endurance. The gold inside it did not change. Gold in ionic solution is still gold. The atoms are still there, still carrying every property that makes gold what it is, just temporarily freed from the arrangement that makes those properties visible. It was waiting in the only way gold knows how to wait, which is with absolute patience and zero deterioration, because deterioration is simply not something gold is capable of. When the occupation finally ended and ordinary life began its slow return, Daniel came back to the building. The shelf was intact. The container was exactly where he had left it. He ran the reverse process, adding the precise reagents needed to precipitate the gold back out of solution, coaxing the ions back into solid form. What settled at the bottom of the container was a fine metallic powder. Dull at first, not the gleaming material people associate with gold, but unmistakably real. He dried it carefully, weighed it, confirmed that almost nothing had been lost. The chemistry had held. The gold had held. That powder was sent to the institution responsible for the awards, and from it, the original objects were recreated. The same gold, the same atoms that had been part of the originals, were now part of the replacements. If you held those recreated awards today and understood their history, you would be holding objects that had been chemically dissolved and reconstituted, that had spent years as an invisible liquid on a shelf, surrounded by people who would have viewed their existence as a threat, and that had survived all of it without losing a single atom. The story of those awards is the story of gold itself in miniature. It absorbs every crisis. It outlasts every danger. It comes back exactly as it was. And yet, around the same time that Daniel was demonstrating what gold can survive, a completely different group of scientists was trying to prove something that cut directly against everything gold's history suggested. They wanted to show that gold was not special, that it was not rare by cosmic necessity or by the fundamental limits of physics, that it was just another element, and that if you applied enough energy in the right way, you could make it from scratch, whenever you wanted. They had access to equipment that Marcus could not have imagined in his most optimistic moments. They had a particle accelerator, a machine the size of a city block that could propel atomic nuclei to speeds approaching that of light and smash them into target materials with energies that genuinely began to approximate the conditions inside a dying star. The physicist leading the project, a man named Raymond, had spent his career working with heavy elements. He understood the nuclear physics involved. He had run the calculations, and he knew that bismuth, sitting just a few positions away from gold in the periodic table, was a viable starting material. Knock out the right number of protons from a bismuth nucleus, and you get a gold nucleus. The concept was clean, the math was sound, the machine was powerful enough to do it. Raymond submitted his proposal, received approval, and began one of the most technically sophisticated experiments in the history of materials science. The result was gold. Real, verified, instrumentally confirmed gold atoms appearing in the target material exactly as predicted. Raymond stood in a facility humming with the energy demands of a small town and looked at data confirming that his team had done what alchemists across centuries had dreamed of and died pursuing. For about the length of time it takes to read a single page of results, this felt like one of the great moments of human achievement. Then someone finished the cost calculation, and the number that came back was so large, so completely disconnected from any conceivable economic reality, that the achievement and the absurdity arrived simultaneously. You could run that accelerator for longer than any human institution has ever existed and not produce enough gold to fill a teaspoon. But that was almost not the worst part. The gold that Raymond's team created in that accelerator would have killed anyone who touched it, and nobody put that fact in the press release. That is the detail that stayed with me longest when I first went through the documentation. The achievement was real. The gold was real, and it was laced with radioactive instability that would begin damaging living tissue on contact within hours. You could not wear it. You could not store it safely without shielding. You could not use it for anything a human being could interact with directly. The dream of manufactured gold had finally been achieved, and the product was essentially a health hazard dressed in the most coveted color in human history. Raymond understood the physics of why this happened. When you force a nucleus to shed protons through high-energy collision rather than through the slow natural processes that produced stable gold over billions of years, you end up with nuclei that have the right number of protons but the wrong balance of neutrons. That imbalance makes the nucleus unstable. It wants to reorganize. It does that reorganization by emitting radiation, shedding energy in forms that pass straight through human tissue and damage it at the cellular level. The gold produced in the accelerator was decaying almost as fast as it was created, transforming back into other elements within days or weeks, releasing energy the whole time. So we had achieved alchemy. We had done the thing that Marcus spent his life trying to do and lost his health doing. And what we made was poisonous and temporary and economically impossible to produce in any meaningful quantity. The universe had, in a very precise way, answered the question of whether humans could manufacture gold with a response that amounted to, yes, but you will not enjoy it. The barrier was not our cleverness. We had plenty of that. The barrier was energy. The energy required to force matter into configurations that nature reserves for the most extreme events in existence is simply not available to us at any scale that makes practical sense. We can gesture at those energies in a particle accelerator. We cannot replicate them. And so the scientific community did what it does when one door closes. It looked for a different door. And what researchers found when they stopped trying to make gold and started studying what gold actually does at scales far smaller than the eye can see, turned out to be one of the most unexpected discoveries in modern materials science. Because gold, the same gold that resists everything, the same gold that sits chemically inert through centuries of human history, the same gold that cannot be corroded or tarnished or persuaded to react with almost anything in the natural world, turns out to behave in a completely different and almost unrecognizable way when you reduce it to particles containing only a few dozen atoms. At that scale, gold changes color. Not slightly, dramatically. A solution of gold nanoparticles, looks deep red, or purple, or blue, depending on the exact particle size, with none of the yellow warmth that makes the bulk metal instantly recognizable. And more importantly, at that scale, gold becomes chemically active in ways that the bulk material never is. It interacts with biological systems. It can be coated with molecules that cause it to seek out and bind to specific types of cells. It can be made to accumulate inside certain tissues while leaving others completely untouched. Gold, the most chemically aristocratic element on the periodic table, becomes, at nanoscale, something closer to a precision instrument. Oncology researchers noticed something about certain tumor cells. They build their own blood supply, and they build it badly, with leaky vessel walls that let particles of a certain size slip through into the surrounding tissue in a way that does not happen in healthy tissue. Gold nanoparticles, engineered to the right size, flow through the bloodstream and accumulate inside tumors through exactly that mechanism, settling in like sediment behind a leaky dam while healthy tissue around the tumor remains essentially untouched. Once the concentration inside the tumor reaches a sufficient level, the particles can be activated from outside the body using a specific wavelength of light that passes through skin and muscle harmlessly. When that light hits the gold nanoparticles, they convert it to heat with extraordinary efficiency, far faster than the surrounding tissue can dissipate it. The tumor cooks from the inside. The surrounding cells feel almost nothing. I find something almost philosophically vertiginous about that. Marcus poisoned himself, trying to extract a secret from gold that would have required nuclear physics to understand. Leonard sent ships to sea chasing a concentration of gold that turned out to be a measurement error. Raymond made gold in a machine the size of a building and produced something radioactive and useless. And then, quietly, without any of the drama of those earlier attempts, researchers discovered that gold at nanoscale could be guided inside a living body to find and destroy diseased cells with a precision that nothing else we have can match. The metal that caused more documented human suffering than perhaps any other substance in history, more conflict, more exploitation, more environmental destruction, turned out to carry inside its own physics the potential for one of the most elegant healing mechanisms ever discovered. Gold did not change. Its properties were always there. We just finally stopped fighting what it was and started paying attention to what it actually does. And that shift, from fighting gold to understanding it, is what leads us to the part of this story that I think matters most. The part that connects everything we have covered, from the neutron star collision that made it, to the planetary gravity that hid it, to the asteroid bombardment that delivered it, to every human being who has ever held it and believed, for a brief moment, that they owned it. Here is what archaeology keeps confirming in ways that I find genuinely difficult to sit with comfortably. Gold does not age. Not in the way we mean when we say something ages. A burial site opened after 3,000 years in the ground will contain organic material reduced to dust, wood turned to powder, fabric dissolved entirely, iron corroded beyond recognition. And somewhere in that same sealed space, a piece of gold jewelry will be sitting in the dark exactly as it was placed there. Every surface detail intact, every curve and texture preserved with a fidelity that no human craft could match across that span of time. The gold does not know 3,000 years past. For gold, those years were not a duration to endure. They were simply a pause between one pair of hands and the next. That is the thing I keep returning to. Every piece of gold currently in circulation has been owned by the dead far longer than it has been owned by the living. The atoms in your ring or your chain or the contacts in your phone have passed through an unbroken chain of human hands stretching back further than recorded history. Some of those hands belonged to people whose names we do not know, whose languages no one speaks, whose cultures left no other surviving trace. The gold remembers none of them. It carries no chemical record of the warmth of those hands, no trace of what those people believed or feared or wanted. It simply continued existing, the same atoms in the same configuration, waiting for the next temporary custodian to arrive. I used to think of that as cold. Now I think of it as clarifying. Because it means that everything we build our relationship with gold on, the idea of ownership, the idea of wealth as something that accumulates and belongs to us, is a story we tell inside a time frame so short that gold does not even register it. We are not gold's owners. We are its current address. A stopping point in a journey that started before our planet existed and will continue long after everything we have built has returned to dust. Every civilization that organized itself around gold eventually ended. Every person who believed they had secured it for their family, their institution, their nation, eventually became someone the gold moved on from. Marcus is gone. Leonard is gone. Raymond is gone. Daniel is gone. The people who made the original awards that Daniel dissolved and reconstituted are gone. The gold is not gone. It is somewhere right now, in someone's hands or someone's vault or someone's device, completely indifferent to the biography it has accumulated across millennia of human history. We did not discover gold. We became one more chapter in its story. And the chapter before us was longer than all of recorded human history, and the chapter after us will be longer still. So here is the question I genuinely cannot stop thinking about, and I want you to answer it in the comments because I think the answers will be genuinely different and genuinely interesting. If gold will outlast every system of value we have ever built, if it has already outlasted dozens of civilizations that believed their relationship with it was permanent, what does that actually say about the things we are sacrificing right now to acquire it? What are we trading away, in time or health or integrity or relationships, for something that has already proven it will simply move on to the next person without registering that we were ever there? Think about that. And if this story made you see gold differently, if it shifted something in how you understand what value actually means and where it comes from, then subscribe to this channel and leave a like. It costs you nothing, and it means more than you might think. We have more stories like this one, and the next one goes somewhere even darker.